Now I'm going to start this game theory, which is a unit 3 of operational research. As we all know that many practical problems require decision making in a competitive situation where there are two or more competitors involved, and also the action taken by one participant depends on the action taken by the other participants in that particular competition. So now here comes a game theory which deals with all those problems. Now, game theory is a study how to mathematically determine the best strategy or the best moves or action for given condition in order to optimize the outcome. Now, strategy here means the moves or action available to the players or available to the participants. Optimize here means that it can optimize the outcome. The outcome can be a gain or loss or a draw. So optimize the outcome means that either to minimize the loss and maximize the gain. Now here in this not all competition can be a game, but competition can be a game if it satisfies the following properties. The first one is there must be a finite number of players or competitors or participants. And number two is each competitor or called the player. The competitor or the player or the participants has a finite number of strategies available to him or her. That means there will be only a finite number of actions or moves that can be taken by a player when in a competitive situation. There will be only a finite number of moves or actions available to each player. Number three is that it must satisfy this condition that a play of the game starts only when each player employ his or her strategy. That means the play will start only if each player apply his moves or action available to him. Now lastly is this one. Each game result in an outcome that is a loss, gain or draw called the payoff to some players. Now each of the game will result in an outcome. Now outcome can be a loss, or it can be a loss to one participant, and it will be a gain to the other participant, or it can be a draw among the participants, and this is called a payoff to some player. Now in our study, we are interested in these two-person zero-sum games where there will be only two players or two participants only, and the game will be called a zero-sum game if the algebraic sum of gains and losses of the two players is equal to 0. That means the sum of the loss gained will be equal to the gained loss to the other player. So here, if the algebraic sum of the loss and gain of the two players here is equal to remains as a constant or equal to 0, then in that case it will be called a two-person zero-sum game. So here we'll in a study throughout, we will consider only a game involving two-person only or two players only. So now to illustrate this one, okay, now so in these two-person zero-sum games, these are the basic assumption. The basic assumption will be the following. Number one is that there will be two players only involved. Number two is the number of strategies available to each player will be finite. Number three, this one strategies available to each player should be finite. Number two, for each specific strategy selected by the player, this will result in a payoff. That means now when a player apply his strategy, then it will result in a payoff. That means it will result either in a gain to loss or a draw among in between them, because there will be only two players. Now the amount won by one player will be exactly equal to the amount lost by the other player. Since there are only two players here, so the amount lost or the amount won by one player will be exactly equal to the amount lost by the other player. Now this game will be called a two-person zero-sum game, since the algebraic sum of gains and losses of both the players will be 0 in this case. So now a two-person zero-sum game can also be represented in a payoff matrix. Now, payoff matrix means that you can represent a payoff among these two players in matrix form. For example, if there are two players A and B involved in that game. Now, suppose both player A and player B toss a coin. There are two coins here, one tossed by player A and another one tossed by player B. Now they toss these two coins simultaneously. So if head comes, if the coin toss by player A shows head, and also that of coin toss by player B also show head, then in that case player B will pay to player A, say a sum of rupees 10. So here what you can do now, what are the strategies here? This is player A, player B, and player A will be along the row. This will be along the column. So now what are the strategies available for these two players? It will be head, tail, and then this also head, tail. So now if both heads appear in the first toss, then in that case, this player B will have to pay rupees 10 to this one. So it will be 10 here, and then if tails come, then in that case player A will have to pay to player B. So in this case player A will have to pay to player B. So you have to write 4 here because tail will come out here, head. Now you see that when player A and in player B will pay to A if both head comes out, and then player A will pay to player B if both tail comes out. So you have to write 4. And in case if head tail and tail head comes out, then in that case player B will have to pay rupees 3 to player A. So since he have to pay rupees 3 to this one, so it will be minus 3 here, minus 3. So this will be the payoff matrix of this game, where there are two players A and B, both are tossing the coin simultaneously, and the strategies here is that if both head occurs, then player B will pay to A rupees 10, and if both tail comes, then in that case player A will pay to player B rupees 4, and player A will get rupees 3 if head tail comes or tail head comes. Then in that case it will be minus 3. That means because B will not get anything from here if head tails come or tail head, so it will be a subtraction from him, so it will be minus 3. That means minus 3 represents that it has that only B minus 3 here means that player B did not get anything here when head tail or tail head comes out. So this will be the matrix representation or the payoff matrix of the game between A and B, where both A and B toss their coins simultaneously. Now let us come to this one, maximin minimax principle. Here, using this maximin minimax principle, we'll try to find out what will be the value of that game. So let us consider two players here, since we are dealing with the two-person zero-sum game. So here we have to consider only two players, A and B. Now suppose player A has M strategies, A1, A2, AM available to him, and player B has N strategies, B1, B2, Bn available to B. Then in this case, we can consider the payoff matrix for player A and player B as follows. So you can write player B here, player A. So along the column, you write the strategies available to player B, B1, B2, Bj, Bm. And along this row, you write the strategies available to player A, A1, A2, AI, AM, and so on. Now from this first column, this last one will represent the row minima. Row minima means that you find out which one is the minimum entries among the first row. Then write it here. From the second row also you find out which is the minimum entries from this one and denoted by R2 and so on. And the last one will be RM denote the minimum entry in the last row. Now along the column, C1 here denote the column maxima. The column maxima, that means the maximum value or the maximum entry in the first column. C2 denote the maximum entry in the second column and so on. Now let us take V bar. V lower bar will be called as the maximum of the row minima. Now these are the row minima, and then you take the maximum of this one, R1, R2, Rm, and that will denote it by V lower bar. And V upper bar will denote the minimum of the column maxima. So there are n column maxima here, C1, C2, Cn. Now you take the minimum of this one and that will be denoted by V bar. So this one is called as the maximum. This one is called the maximum value of the key, maximum value, because it is the maximum of the minimum row minima, and this V upper bar is called as the minimax, that means the minimum of the column maxima. Now if these two values are equal, then in that case then the corresponding strategies where this V up lower bar and V upper bar occur will be called as the optimum strategies for player A and player B. That means which will be the which strategies did player A need to apply and which strategy did player A need to apply in order to optimize optimize the outcome. Now when you solve the problem, you will come across this one where the maximum value of the game occur at a particular position, of maximum and the minimax value occur at a particular position, and that position will be called as the saddle point. That means the position where this V lower bar and V upper bar occur will be called as the saddle point of the game, and it also will and the value of this one will be called as the value of the game. Now for example, in this one we can use that maximum minimax principle. So here you see that in this pair of matrix you can find out what will be the minimum entry, will be mark it by star. This is the minimum, and here this is another one. In the third row this is the minimum. Now the column maxima will be this. The column maxima here will be this one, and here it will be this one and this one same. Now you see that here we have 6 here, 6 and 4, and this one is 9 and 6. So here the column maxima will be this one, 9, 6, and the row minima will be that one, 6, 6 and 4. So now what is V lower bar? It will be the maximum of the row minima. Maximum will be 6 here. And what will be V upper bar? The minimax or the minimum of the column maxima, it will be 6. Now in this case you see that V lower bar is equal to V upper bar. So therefore the value of the game will be equal to 6 here. And this occur at this position. This position here and this position. That means when player A apply strategy A1 and player B apply strategy B2. Or player A applies strategy A2 and player B apply the same strategy B2, because it occurs in the second column and the second row. So the optimum strategy in this case will be either A1 with B2 or A2 with B2. So this is the application of the maximum minimax principle. So you'll see that in all the problems we have to apply this principles only to find out the value of the game and to find whether the given game is strictly determinable or it is a fair game or not. So that one we will discuss in the next class regarding that regarding the strictly determinable game and a fair game. So here I hope it is clear now how to find the value of the game, and if V upper bar is same as V lower bar, then that one will give you the value of the game. And also from this particular example you'll be able to see that what is the best strategy for A1 and for A and B to apply in order that they will have an optimum so that the outcome will be optimized. That means it can will be gain for player B, the gain will be maximum and the loss will be minimum to player B. So please go through again so that it will be more clear to, if it is not clear, you please let me know.